Dealing with parameter arguments. This is actually one of my favorite spots because their languages are all over the place when it comes to, well, not really the setup, but what options you might have, especially I'll go over the spread one here in a second. But remember, there's explicit and there's implicit parameters. Explicit is when you're telling it, you're putting double quotes around it, or you're literally putting in the number when you're calling it, saying this is what it's going to be. Whereas the implicit, it's from a variable or some type of object, and we don't know exactly what's going to be, but it's still going to be passed in there. Now in Scheme, you do have both options, and you should have probably used them before in whatever language that you probably had before. I think Python Scheme, sorry, Python, C++, Java, they all use that, so shouldn't be any big deal when it comes to that. Now some of the functions are going to accept a fixed number of arguments, such as the Scheme or Haskell's cons. There's going to be some that accept any number of arguments, like an like a plus symbol in Scheme, and I'm going to go over that here in a second. And then there's going to be some that accept a range of argument counts. It's like substring accepts either 1, 2, or 3 arguments, but not super many. Let's just put it that way. Now, out of all the arguments that you see here, there's two things here. Number one, be very careful that in the examples here, you might see what's called the smart quotes, and that's quotes that are actually literally diagonal a little bit. There's a big difference between a smart quote and then a regular double quote. Be careful on what your particular flavor works with. 99.9% of the time it's going to be the non-smart quotes where it's literally 2 quotes and they're going straight down. There's no angle to them, so be very careful. It might be my set of notes that might have changed that, so be very, very careful if you were to copy and paste. And anytime you see quotes like that, be very, very careful about it. But anyway, you know about passing integers, strings, multiple values, and another function, which we actually will get into in higher functions here in a couple weeks. But the one you may not be used to is called the spread operator. And in the spread operator, which I'm going to go into a little bit more, is that this allows you, you're going to have one parameter, which is x, could be named anything, and then you're going to have unlimited number of parameters after that. Now again, I'll go into more detail here in a minute with it, but JavaScript actually is one programming language that does use the spread operator, but it's not always consistent in some of the other ones, the big ones like C++ and Java. So again, function design wise, you have to realize what opportunities and, well, options that you actually have. And that's one item that you really need to consider and check to see if your particular programming language has. So just a heads up on that. So Scheme does offer a nice feature called the spread operator. Now it's actually a little on the tricky side to use because what happens is it's going to accept one value for a function, and then the rest it's automatically going to place into a list. Now this is the first time you're probably going to see a list in Scheme for some of you, so just bear with me here and we'll go from there because we're going to get into lists very, very heavily in a few weeks, if not next week. So, but heads up on that. So what I'm showing you right now is something that the student thought was going to work but didn't. So this whole block, it's not going to work. Now the funny part is the function header was right. We're going to define and add. We're going to accept one parameter first, and then the dot is the key, is the spread operator saying, hey, there's going to be one or more values that we're passing in here, and we're going to name it and put it into the list called rest. Now, rest and x could have been named whatever the heck you want. We just use that for this example. After that, the student wanted to add the A to the rest of the list and go through that and thought it was going to work. So the student tried all these examples that you see here. First, it was trying to do add 23, 42, and then a couple more numbers. And then the student tried to do 23 because, again, the first value is that x. That's what you got to match with first. And then the rest of it's whatever. And the last 3 examples there, that's actually creating a literal list in Scheme. And the student's like, wait a minute, I'm doing this right. Why is this bogging up? Here's the bad part. Is that, remember that, like I said, whatever is after that dot is literally going to be a list. So we have to treat it as a list. You've dealt with lists before in C++, Java, whatever. You got to go through each item in the list. And that's actually what is happening here. So here's our add function. But notice we're going to create a helper function called, what is that, list help there, or list sum. And that's actually you use recursion and iterate through the list to grab out each one, add them together in order to basically finalize our list. Now again, this code here is going to be foreign to you, and that's okay. I don't want you to really, I want you to understand it eventually, but it doesn't have to be right now. But what I do want to make sure that you understand is that if you happen to use the spread operator, we have to do some functions that deal with lists because it literally is going to be a list from here on out. When we got through this, we tested things out, and notice with our display, and when we added different numbers to it, it displayed just fine. The funny part is that when we tried to put them into a set list or literal list, the funny part was Scheme had an issue with that because it didn't work because we're actually making a list of a list, which can be done if you've gotten to this level. So this code got super ugly. That's not what we wanted. But actually, in reality, look at the two sets. Isn't it easier just to kind of create it that way in order for it to work? So it really worked out pretty nicely with the spread operator after we knew what was going on, and that we actually have to use list functions in order to solve what we actually know, which again is not currently what you guys know yet, but it will be soon. So just heads up on the spread operator is another option that not just in Scheme, but in other languages like JavaScript have. So you keep that in the back of your mind in your design.